Okay, so I've written this one out, but this would be the question here. Prove that for any integer n, the floor of n divided by 2 is either this, if n is 2k, meaning even, or this, if n is 2k plus 1, odd, right? So we're going to be bringing in that, breaking things up into cases more often. So let's do the case if n is equal to 2k. So if n is equal to 2k, then this left-hand side here is n over the floor of n over 2, which is the same thing as saying 2k over 2. Oh, look at that. We'd have the floor of k, which is k. Okay, so then if I have this right-hand side here, right, n over 2, substitute in 2k, I get k. So I get this equals this. Good. Now let's do the case for n equals 2k plus 1. So for n equal 2k plus 1, the left-hand side, which is this, substitute in the 2k plus 1. So then break this up around the addition in the numerator, right? 2k over 2, which is k, right? 2k over 2, which is k, plus the 1/2. So what's the floor of k plus 1/2? It's going to be the integer that's smaller than or equal to it, so that's going to be k. All right, let's play with this right-hand side now. So this n minus 1 divided by 2, substitute in for n, the 2k plus 1. Then the 1's cancel, so I get 2k over 2, which is k, so they equal again. All right, so that was one with me writing everything out for you. So now let's go play with this one. So you're going to have to get in the habit of making some bold math statements by starting a proof by saying let something. So since I've got this ceiling of x here, I'm going to say let the ceiling of x equal n. And where I know, so what do we know about this? So I'm just going to put this little, double bar arrow thing. This means that if that's the ceiling of x, then this is true, right? This is a fact. So you want proofs, you always want to start with facts, use them. So the ceiling of x is n. If the integer that's greater than or equal to it is itself, is n. Not itself. It's greater than or equal to x is n. And when the n minus 1 is smaller than it. Okay. And I should say n is an element of the integers, right? Okay. So where am I trying to go? I want x plus 1 in my ceiling. So let's take this line right here and add 1 everywhere. So I have n, x plus 1, n plus 1. So what does this line right here tell me? This tells me that the ceiling of x plus 1 is n plus 1. Oh, now I think about where am I going? I'm trying to get to this right-hand side, correct? So I've got the left-hand side right here. I think I defined the ceiling of x as n. So there it is. So the ceiling of x plus 1 is the ceiling of x plus 1. All right. So let's do the same kind of thing with the floor, right? So again, I'm going to let the floor of x equal n, n being an integer. And what does that mean? That means n is smaller than or equal to x is smaller than n plus 1. So just knowing the definitions. So now thinking about where I want to go. I think I want to subtract 1 from everywhere. So on this line here, I want to subtract 1. So subtract 1, subtract 1, subtract 1. Okay. This tells me that the floor of x minus 1 is n minus 1. Okay, so think about where I want to go. This is my left-hand side, and I'm looking at this right-hand side. Oh, there it is. So the floor of x minus 1, I can substitute in for n, the floor of x minus 1. All right, let's see. So if you kind of take a look at these two, really similar, right? So this has if-then, and the if-then switched, right? So when it's an if-then, you can't go back and forth. You have to start with this, and then find that this is true, right? And this side says start with this and then find that this is true. So making sure that you start with the right side, the right direction. All right, so if D divides N, what does that mean? So that means N is equal to dk, where k is an integer, right? Okay, so let's look at this. So now I'm going to find out that this is true. So I'm going to start with this side. So I'm going to start by writing that down. And then I'm going to substitute in dk for the n. The d's will cancel, so I get the floor of k. Oh, well, what do I know the floor of k is equal to? K. So I get kd. And what do we know that that's equal to? That's equal to n. So I got there. So I got this is equal to this. All right, now let's play with it the other way. So if I start with this, I want to get to here. So here I have this floor of n over d. So this is where I'm going to just make the bold math step, and I'm going to say the floor is equal to k. Right? Just let that equal to a k, or whatever letter you want, where k is equal to an integer, right? Then what do I know? If I have n, which is equal to, this is my if, right? So I can start with this, n over d times d. Now I'm going to substitute in k, right? So I get kd. So from this, I get n is equal to kd. N is equal to kd. Oh, what does that mean? That means that d divides n. I made it there.